Hi and welcome to another of the DTA screencasts, and in this session we're going to obviously be looking at muscles. Okay, so there's going to be a certain amount of assumed knowledge from your GCSE, and one of the things that we're going to be making sure that you know, or you should have checked before, is the names of all the muscles. So essentially what we're going to do is, instead of calling something like the calf, we now use a technical term which is known as the gastrocnemius or the soleus. So what you need to make sure you do before your next session is know each one of the correct terms for each one of the muscles. Okay, so a lot of the time we're trying to apply this to practical situations. So we're going to talk about muscle movement, and essentially one of the things that we must all understand is that muscles can only pull. There's no pushing action. That doesn't mean to say that you can't push, but we'll try and break that down into a bit more detail. So in this small situation, we're going to identify that it's now the bicep brachii, which is obviously this muscle here, and the contraction of that muscle pulls on the bones to cause the movement to happen. Very, very straightforward, and I'm sure you've understood this from your previous sessions. The other thing that we've got to make sure we identify in our answers is the fact that the tendons are the attachment between the muscles and the bones. I think pretty straightforward, so making sure that you remember that, we will move on. So the next thing we need to make sure we identify from GCSE is the concept of the pairing. So the agonist pairing is what they're called. So we have our bicep here, and obviously that's the one that's contracting, but now we also have the tricep, which is relaxing at the same time. So that allows the movement to occur. So if you had both of them contracting at the same time, we wouldn't create movement. So one has to contract, therefore moving the arm upwards, and the tricep, as you can see, there is a lot smaller, therefore it's not contracting, and that's allowing that movement to occur. So it's an agonist pairing. So you can see in this situation here that now that the bicep has relaxed, allowing the tricep to contract, pulling the arm down. So the agonist has now swapped over to the tricep. Okay, so we will go over those more in the session, and as that's the foundation of what we're going to be talking about. So next thing we're going to be looking into is the different types of contractions. Alright, so there are three different types of contractions that we talk about at this level, and the first one is the concentric contraction. So as you can clearly see there, the muscle length is shortening. So as the arm moves up, the muscle is contracting and reducing the distance between those two particular points, and therefore shortening. So let's take a look at an example of that there. So as you can see, we have the rise as we lift the dumbbell up. The bicep is the contracting muscle, and it's shortening and therefore creating the contraction. So alternatively, what we also have is an eccentric contraction. So this is where the muscle length is going to increase. So as the dumbbell is lowered down, the bicep is increasing in length, but it's the one that's still contracting. It's lowering it down very, very gently against gravity, and this is known as an eccentric contraction. But note that it's still the bicep that's the working muscle, and that's where a lot of people get confused because of that concept of the pairing. It's still the same muscle that's working, but now it's lowering down nice and gently. And if you do that yourself practically, if you lowered that dumbbell down, you would notice that that is the muscle that still works. I'm sure you would recognize that very quickly if you use quite a heavy weight. And that's your eccentric contraction. Okay, so for the last one, what we're doing is identifying here clearly that the contraction still... Okay, so what we're doing here is identifying the fact that these are known as isotonic contractions, contractions that have movement. It's absolutely essential that we understand that the concentric and eccentric contractions are known as isotonic, not to be confused with the next one that we're going to look at that has a contraction but no movement. So this one is known as an isometric contraction. The muscle length is going to stay the same. So can you think of an example where a muscle is going to stay the same but there's no actual movement? So what could you think of? Sporting example, probably one of the easiest ones I could think of is the plank. Or another one is the crucifix when we're thinking about the rings. So there is definitely a contraction taking place. Those people are definitely working, and if you do the plank yourself, I'm sure you would recognize that. But there's no particular movement. Obviously that person is staying still. And what this shows when this person's doing this exercise is they have a strong core, and it's known as your core stability. So that's the erectus spinae, or also your abdominals as well. All of the muscles around that core that are allowing you to stay in that strong position. One of the things you've also got to recognize about the core stability is it supports most physical activity from the arms and legs. So if you keep your core nice and still, you're allowed to have greater ranges of movement. The other thing it does as well is reduce the risk of injury. If anyone's ever slipped a disc or had a spinal injury, one of the things they'll try and do is get you a really strong core to keep all those bones in place. Alright, one of the other things that we need to pick up from our GCSEs to our A-levels is the relevant terminology. Now, we still have the hamstring group, they've not been taken away, but what we need to do is recognize each one of the individual muscles as opposed to the group from now on in. So, as you can see down here, there's the bicep femoris, semitendinosus and semimembranosus are our hamstring group, and to score on any exam we need to be identifying each of those particular muscles. If we state the hamstring group, it's too vague and they're not going to give us the score, which is a real shame because I'm sure it's very easy to learn each one of these names. Okay, and exactly the same is going to take place with the quadricep group. It's using the correct terminology. Vasta intermedius and rectus femoris, vasta lateralis and vastus medialis. Quadricep group won't score, as I mentioned before, identifying the individual muscles. Okay, and one of the other key differences we need to look at between GCSE and A-level is the mention of these muscles, so the rotator cuff group. So these muscles, as you can see there, are talking about movement and stability, but again, there are muscles within that group that we need to identify. And the easy way to remember is SITS, S-I-T-S. So you have your supraspinatus, subscapularis, teres minor, and the infraspinatus. What we also need to be able to do now is look at what type of movements these muscles allow us to have. And this one for the rotator cuffs is really clear. It's known as a lateral rotation. So we're moving the arm from an out, from an in to an out. So a perfect example we can think about is the backhand in tennis. So you're moving from something that's inside the midline and then you're moving it away. And then vice versa is medial rotation, so it's moving towards the middle, so it's the same letter. And the example I probably think of is the completion of a tackle in rugby, because you have to move your arms from the outside of your midline and you move them towards the middle as you wrap your arms around there. So it's moving from the back there and it's moving forwards round to the front. And this is known as our medial rotation. Okay, one of the other jobs of the rotator cuff muscles is stability. Now this fella here clearly at this point has not had some stability, and so the rotator cuff muscles are there to actually prevent dislocation. On that shoulder there, nice and normal, but obviously on the first shoulder he's dislocated it. So those rotator cuff muscles are there to keep that shoulder intact and in place. And the key thing that happens there is you have the dislocation. So they have two jobs, one for movement and then one for stability. Okay, so make sure you pause the screencast, go back over any of the components that you're not sure about, make sure you make notes, use the Cornell method if that's good for you. Okay, and I'll speak to you again soon. Thanks very much.